Welcome to Brain Vision.
Okay, in this question, we have a square plate with side length b equals 0.2 meters that is rotating currently with an angular velocity of 1.4 radians per second and an angular acceleration of 2.5 radians per second squared in the opposite direction. And we want to come up with an equation for both the linear velocity and linear acceleration at this instant in time. So to do that, we need to write, not omega here, but the velocity. And we're looking for this velocity and acceleration of point A down here at the bottom of the square. And it's rotating about point O up at the top. So the velocity will be r times omega. And we need to be a little careful here because the omega they give us is for rotating in a clockwise direction, but we usually are looking for a counterclockwise direction here. So we need a negative sign just to correct for the direction they gave us. And then we need to break this down into components. And the components will be a 45 degrees minus our angle in the I hat direction, plus a sine of 45 degrees minus theta in the j hat direction. And we use the cosine because and the 45 degrees here because in its vertical position here, all of the movement will be in the x direction, so the I hat direction. And at 45 degrees, then the j hat term would be 0. So when we put the numbers in for this, we would find that we have a velocity of negative 0.382 I hat meters per second minus 0.103 j hat. And the units again are meters per second. And we can do something very similar for our acceleration. The acceleration will be r times alpha now. And we don't need the negative sign here because the rotation or the alpha is pointing in the counterclockwise direction. And we again have this cosine of 45 degrees minus theta for the same reasons as before, times I hat, plus the sine of 45 degrees minus theta times j hat. And when we put the numbers in for this, we end up with a 0.683 I hat. Let me fix that real quick. Plus 0.183 j hat meters per second squared. And we can go ahead and just double check that this is roughly correct. So initially, we had an angle of 30 degrees, which means that this point A is actually over to the right because this angle theta here shrank. So the entire square was rotated to the right a little bit. And at that point, the velocity vector for that point would be rotating back towards the current position or the black position of A there. So that'll be down and to the left, which is the direction we got here. And the angular acceleration would be up and to the right, which is what we found for our acceleration.